After understanding the thermodynamic and electrochemical principles of metallurgy, now let us understand the use of oxidation and reduction reactions in metallurgy. See, we know we have been talking about the reduction of the metals from their oxidized state to their reduced state. We have been knowing this. But yes, oxidation is also used for this purpose, for the extraction of elements. And of course, as the word comes oxidation, it means you need to understand we'll be oxidizing a species which is already existing in the reduced state. So it's mainly used for non-metals. Non-metals, like we can take the example of chloride ion, which is already existing in the reduced state. If we want to obtain chlorine, it has to be what? Oxidized. So oxidation, remember, is mainly used whenever we have what? Non-metals present in the reduced state. Now this, like chloride ions which are existing in the aqueous state, we can take the example of brine solution. Brine is NaCl aqueous solution, or the seawater. Now in this, lot of chloride is there. If you want to oxidize this chloride, I can write here again. If you want to oxidize this chloride, we need to know what its reaction with water is somehow like this. It is OH minus, H2 and Cl2. So what exactly we get is this reaction. Now in this, what we find is, if you make it twice, it will be twice, and this is how it can be balanced. Now in this reaction, what we find is that the chloride ion is oxidized to chlorine, and the water actually is getting reduced to give you hydrogen gas. Now this reaction cannot take place on its own because its delta G is positive. Now once its delta G is positive, you can easily imagine its E naught will come out to be minus, negative. Once its E naught is negative, it means what? It will not take place on it. So definitely it is used, what? By using external source of energy in the form of electrical energy. So what we do is we will do the electrolysis of brine solution, where we get chlorine at anode, and we get hydrogen at cathode, and NaOH is left out as such. So this is the very nice example to explain that yes, oxidation is also used to obtain what? The elements. Because but remember, it is only used for those elements which are existing in the reduced state, and those are mainly are the non-metals. Now let us take example of reduction. The most common example to explain the reduction is your forest cyanide process, which we have already done in the leaching. Now in this forest cyanide process, which is used mainly for gold or for silver ores, what we do with this, the ore is actually dissolved in what? Cyanide solution, 0.5 to 0.7% sodium cyanide solution, presence of oxygen. Now what happens is, like if we have a gold and it is dissolved in cyanide solution in presence of oxygen and water, what happens is the gold gets dissolved in it and it forms this type of complex, minus plus OH minus. So it will be somehow, it's this reaction which is taking place like here. Now what we find in this case is that the gold which has been actually there is further first is oxidized from 0 to +1 state, and now by using more reactive metals like zinc, here it is reduced again like this. So in this case, mainly what is happening is we are involving the oxidation of the impure metal ore, the ore, or we can say the impure metal, which is further actually converted into a complex in the oxidized state, and then it is reduced by using more reactive metal to what? Obtain the pure metal. So both oxidation and reduction are involved. Mainly this step, this is called leaching or chemical separation. This we have already done, and this is the part where actually reduction is done in which the metal gold or silver is reduced to their atomic state. So this is what is the best examples to explain oxidation and reduction.